Good afternoon, ladies and gentlemen. I'm Christian Brand, the CTO for Entersekt, and today I'm here to chat a little bit about mobile security, or I think the general lack thereof in banking applications. So as smartphones are becoming more and more powerful, users have been demanding more and more services on these devices, and security often gives way to functionality, which can leave users exposed. So if we have a look at some of the statistics here, I think one of the major problems with the ecosystem is that up-to-the-minute expertise is lacking. There's fragmented approaches to data security. Statistics like Gartner that says 3 out of every 4 mobile applications will fail security tests through 2015. And an interesting study by FireEye saying that 68% of the top 1,000 apps in the Google Play Store is vulnerable to basic man-in-the-middle attacks. And if we drive this a little bit closer to home, if we look at just banking applications, IOActive done a survey on the 40 top iOS mobile banking apps from the world's most influential banks. And we see things like 90% use non-SSL linked, 50% were vulnerable to JavaScript injections. And, you know, just basically today it's card breaches or magnetic stripe card breaches at Home Depot and Target on Windows platform systems. Tomorrow, I think what we're going to start seeing is these same types of attacks, but on iOS and Android. So let's shift gears to user identity quickly. Online, we're all used to identifying ourselves and providing information through user ID and password to banking systems. That's the primary way of authenticating ourselves to these platforms. We provide the user ID at the point in time where the bank receives it. They authenticate us and allow us to get in. Unfortunately, user ID and password is easy to compromise. Phishing, man-in-the-middle, man-in-the-browser, a bunch of different ways in which fraudsters can get into this data and get hold of it and use it against us. So most banks have started to adopt certain technology called two-factor authentication, which essentially allows us to prove possession of a physical piece of hardware before allowed access to that resource. So typically, if I want to sign into my banking account, provide my user ID and password, bank sends me a little SMS one-time code to my phone. I then enter it into the browser on the app, and once all of this is entered up, I'm proving that I own or have physical possession of my phone, essentially by typing in this key code into the banking application. And consumers are getting ready for this technology. Guys like Facebook, Google, Salesforce, LinkedIn, they've all adopted the practice of multi-factor authentication. And I think it's clearly good practice, since it makes it harder for fraudsters to gain access to your account. But the question is, how do we do this and implement it in a safe and easy-to-use way on the mobile side? So, you know, the first thing I can say is these little SMS and one-time codes is not the best way to do it. Markets that have adopted this early are already replacing it. It doesn't protect against man-in-the-middle, man-in-the-browser, and we'll get into that in a couple of minutes here. And in 2012, the lobby group for the Australian telcos or the mobile carriers went as far as saying SMS is not an adequate way to protect yourself against banking threats. It's definitely not practical for mobile app authentication. It's a very poor user experience, having to swap apps, getting an SMS, going to your inbox, copy and pasting a code. It can't be used for transaction signing in territories like Singapore and Korea and Taiwan, where this is mandated, and it can easily be stolen by malicious software running on these devices. So what about the encrypted bits and bytes exchanged between our mobile applications and servers? You know, mobile apps traditionally make cryptography the operating system problem. If we develop a mobile app, we use constructs like HTTPS, ://, and let the operating system take care of the encryption. And essentially, we're placing all of our bets on one single cryptographic channel. The Monetary Authority of Singapore, which is widely regarded as probably one of the most progressive thinkers in the space of banking regulation, is even calling on banks to roll their own crypto to try and mitigate this issue of placing all your bets on one channel. And if we go, you know, look at the notorious iPhone go-to fail bug of February and subsequently Heartbleed on the server side, we really start to see an interesting pattern emerge. So the solution we propose and used by numerous banks really is kind of the idea of deploying an SDK inside a mobile banking application. We call the SDK Entersekt Transact. Essentially what that does is it enables a second cryptographic channel on that mobile device that you have. That cryptographic channel with the crypto is self-contained within the SDK, so we don't use the device crypto. There's a digital certificate installed on that inside that SDK with a unique private key, which essentially allows you to identify every mobile device that connects into your infrastructure uniquely. That cryptographic channel is directly from within the application. We don't share device OS crypto. It goes straight from that application back to a hardware or a software appliance on the bank's premises. services called the Transact Secure Gateway, really giving you an additional way, an additional second channel to authenticate transactions through. So essentially, without your physical phone, any stolen credentials is worthless to a fraudster. And essentially what it gives you is transparent two-factor authentication on one single device. How easy it is to implement? Really straightforward. You call the SDK Connect function the first time you want to use the SDK. It automatically generates the keys in the background. You can use the get trust token method to easily integrate this second channel into your application and verify the authenticity. So we make sure that both of these cryptographic channels you have active is actually secure. And you can even send traditional two-factor authentication messages through the channel as well, regulating or trying to stay within the guidelines of the regulation, FFIEC, for example, by actually sending two-factor messages to the same physical phone. Very important. So essentially, your application, our authentication, build customer trust with this, improve customer satisfaction, save time and money, not be the next Home Depot and Target. Thank you very much.